In this video, we're taking a look at the TryHackMe Advent of Cyber 3, day 18. And we are getting into some cloud material, so I'm super excited for it. And let's hop on over to the screen, because honestly, I don't really know what I'm up against just yet, but let's go ahead and dive in. Alrighty, so I have the TryHackMe Advent of Cyber 3 room pulled up, and I'm going to scroll down to this day 18 called Playing with Containers. It says, please note, if you're on the TryHackMe free plan, the attack box does not have internet access and cannot reach AWS. You'll need to install curl and the AWS CLI on your own machine in order to complete this challenge. Instructions for installing the AWS CLI are here, and we can go ahead and open that up in another tab or something. But let's continue onward anyway with the premise of what this task is. It says, Grinch Enterprises has been gloating about their attack on an underground forum. We know they were specifically targeting organizations in a campaign they've themed Advent of Cyber. What a frustrating coincidence. Tracing the user back over time, we also encountered a reference to using AWS Elastic Container Registry, or ECR, to store container images they use as infrastructure in their attacks. Let's see if we can find out more about the attack tooling that Grinch Enterprises is using. So for getting started, you'll need to start your attack box to run commands using the Docker container tool. Containers are a virtualization mechanism similar to virtual machines, and container images are based on the Open Container Initiative distribution specification. However, when someone talks about Docker or containers, they're often talking about multiple container technologies that work together. Specifically, the term Docker is used to describe the Docker API, a local communication interface on a configured Linux machine with standardized commands used to communicate with the Docker daemon, or some service running in the background. The Docker daemon is a process that runs on your machine to interact with container components such as images, data volumes, and other container artifacts. The Docker container image format is ultimately a .tar file or a tape archive. For version 1, the Docker image format was not strictly compliant with the OCI image specification. For our purposes, this won't change how we interact with the container images in this exercise, but it does slightly change the format and content of a container image. Now that we've gotten some of the basic terminologies out of the way, let's get started with today's learning objective. So today's learning objective is AWS Elastic Container Registry and the ECR public gallery. We'll be covering the basics of container images and the AWS Elastic Container Registry, or ECR, an online and public-private registry for container images. We'll learn about how to retrieve a container image from an online registry and inspect the elements of that container image to identify potential security issues. Now, Docker images and Amazon Elastic Container Registry differ in some ways, but they are very similar. In a cloud-native computing environment, containers are a first-choice solution for deploying infrastructure. Similar to virtual machine, containers serve as the compute fabric for many running applications and hosted processes in the cloud. Once you've logged onto the attack box, you can run the following command to see container images that are stored by default on your attack box. You can see Docker images as the command, which should return an output similar to the following. Now, I am not running on the attack box at the moment. I am running on my own virtual machine, and if I were to spin up a terminal, I'll move into a directory. I suppose we can call this AOC, just for the sake of having a place to live. Now, I do have Docker installed, and if you wanted to install this on your own machine, you will need to sudo apt install docker io, or whatever package manager is appropriate, right? I'm currently using apt, being on an Ubuntu or Debian-based system. If you do this, you will need to add your user to the Docker group so that you can naturally work with the containers. Some folks say, hey, this is a privilege escalation vector, to which it is a valid point. You should be using it on a host that you are trusting and comfortable with, or a user that you know could escalate to root, considering the fact that they have availability within Docker. So this is the command that you really all need to do, and then it would be like a sudo usermod tac-ag docker and then your username to add it into the group. You'll need to log in and back out, but whatever, ultimately you'll be able to run the Docker command. Now that will give us a lot of options as to what it could do, but notice that images will list images. And I happen to have a good amount of these container images probably already set up because I've done so many things between other challenges that I've written or I've played with other tools. And I say challenges as in like, hey, capture the flag or things. And you notice I have a lot of kind of leftover dangling broken images that noted as none here. But there are some good, interesting things here. And really the gist is you use the Docker images command to be able to list out the repository or container image name, tag, image ID, and when it was created, etc. With that said, let's continue. It says Docker containers are stored in repositories, which are a reference to file mappings that the Docker daemon knows how to reach, which include the container.tar file, or multiple files. Each image in a repository will include an image tag, and images can be referenced using either their tag or image ID. For example, remnux/syfy latest, or some seemingly a hash-looking identifier that is not an identifier, or excuse me, it is not a hash, but it is certainly an identifier, just a string of hexadecimal characters. Now, the Grinch Enterprise attack infrastructure. We've traced the Grinch Enterprise's attack infrastructure back to an Elastic Container Registry that is publicly accessible. And here's that link right here. There is a given link, which we can open up in another tab. I've hit Control on my keyboard as I clicked on that. It says you can retrieve the potential Grinch Enterprise images by running the following command on your attack box. You can run docker pull public ECR AWS / some random identifier Grinch tac AOC : latest. So the latest tag is being pulled down. This will return output similar to the following. Let's go ahead and grab that and try and do this exact same thing. Let me verify I have spun up this other tab for us so we can explore this repository as needed. And now let's go ahead and run that command right in our terminal. I've copy and pasted this so we can docker pull that image. And it should take just a little bit, but as you can see, it is slowly starting to pull this down. It'll go ahead and download. It'll go ahead and grab all this as needed. But again, if you're on the free version of TryHackMe, your attack box does not have internet access and it won't be able to reach this. So use your own machine or spin up Linux, all the good stuff. I personally am a fan of, doing it on your own with your own machine because you can save all your notes and your tools and everything that you might need. You can then run the container and interact with it by running the following command, docker run and tac it. Now, the tac I stands for interactive and the tac t stands for, terminal support, or using it on the command line of the terminal. At least that's how I remember it. Tac it is just about always how you'd like to do things interactively within your terminal, right? And then you'll give it the image name that you'd like. If you don't supply a tag, I believe it will choose the latest one. So actually, let me copy this and actually specify it without using that latest tag at the end there. If I could type, my microphone is in my way and I'm testing how well I can type without looking at the keyboard. Goodness, I'm bad at it. But let's try it without the tac latest or the latest. And now you can see I've been given a $ prompt, which kind of indicates, I am in a command line. I'm in a shell. I could try and do things like run ls tac a. Okay, so are there no current files in the directory that aren't hidden? Everything that has a dot or period prefix is a hidden file, so I could use tac la to list all, really. I could run who am I, and I am currently the new user, pwd, I am in my home directory, and that's the gist, right? You can see ls tac la shows there are no regular files or subdirectories in the present working directory. Spoiler, a good place to check next are the environment variables. In Linux, and especially for containers, environment variables may be used to store secrets or other sensitive information used to configure the current container at runtime. So we could try to use printenv to learn more about the environment variables or the configurations where we see. Now, this is a very, very solid point. For folks who have been kind of jamming with the whole log4j shenanigans, there's some conversations of, you might be able to actually exfiltrate or pull down environment variables. And inside of a container or inside of cloud hosted infrastructure, there could potentially be sensitive information there like AWS private keys or Kubernetes secret keys or just shenanigans and things that are sometimes given in environment variables, and inside of a container, maybe those are accessible. Anyway, you could do this with, I believe, the env command just as easily as printenv, as was suggested in the TryHackMe room. And you can see there are really the normal things. Here's a host name, a randomly generated host name for the Docker container, our home directory, the terminal, and our path for binaries that we might want to run. We also have the present working directory, or pwd, as you saw, but there's this interesting one called API key, which again could very well be sensitive, or any sort of keys or secrets. This is this string right here. I'm going to go ahead and copy this just in case we need it later, but let's keep reading. It says, we've actually stumbled on that API key, which I'm guessing Grinch Enterprises didn't intend to leave behind. Now here for the bonus challenge. A container image is composed, of a number of layers. Perhaps there's sensitive information in an underlying container layer that Grinch Enterprises didn't clean up as part of their build process. Now, when you try to make or create your own Docker instance, and I'll show you this, right? If we were to try and do like hey, let's make a cheesy Docker file, and I don't know what I happen to have in this Sublime window. I don't know what might be open, but we could do like a from Ubuntu like latest or whatever, and then we could run echo hello or set the command or the entry point to anything that we might like, blah, blah, blah. We could really just make our own Docker image. And we could go ahead and Docker build this. Microphone's in the way. I can't type. And we could give it a tag that we want to call this thing. We could call it my container, and then Docker build the location that we want to build or where our Docker file might be present. It is in our current directory, so I could actually just use the period to denote our current directory, right? I'll hit enter on this, and it will go ahead and build it and tag that my container to the latest rendition, right? Now, just using this as an example, and I realize I'm just kind of pulling it out of thin air. If we wanted to Docker run tackit my container, let's see. Oh, looks like it made it interactive, right? And just threw together a simple shell for us. If I didn't run that interactive, part of me wonders if it would actually run the echo command. It might not display it out on the screen, truthfully, because, this is going to be wacky because I didn't make it interactive and now it's not sure what it's doing. In this case, we could use something like Docker PS to see what public containers running containers are running, right? PS, much like you're used to the PS command to show processes, it's like, hey, what are my running Docker containers? You can see the container ID, and this is zoomed in a bit way too much, but I'll try that one more time. Here we go. I'll also full screen this so it's easy to see. Given a container ID and an image, also a name, we could try to Docker stop by the name, busy, or even the container ID, A0, blah, blah, blah. And that will try to stop it. As you can see, that has closed that session or the Docker container that I was running up there. I was going down this tangent, though, because if we were to make more changes, as we rebuild it or made new additions to this Docker container, that is how we're adding layers or making new things being added into the container. All of those changes, much like a Git version control thing, are things that you would be able to maybe peel away or explore as you visited other segments of how that container was built. It's just an onion, and you're peeling the layers off as you start to understand what was the original instantation of this Docker container. So that was a big, long derivative tangent that we probably didn't have to go down, but it brings us closer to this idea that there are layers to a Docker container image. Yeah? Cool. One key reason that developers and attackers might package their application or attack tools in a container is that a container allows developers to freeze an application and its dependencies into an image as part of the build process. The build process is part of that software development lifecycle, where applications and their dependencies are packaged together and tested prior to distribution and use. Once an image is built, running the container image will always result in the same configuration state as specified at runtime. Container images are built from a source file known as a Docker file, and you just saw me kind of cram one out or put that together. Docker files are a list of new line separated instructions that instruct the Docker daemon how to generate or how to build a container image. You can read an exhaustive explanation of how to write Docker files in the Docker file reference. Now I've gone ahead and opened that tab, and if I were to explore this, you could see exactly what I had just done moments ago, where I would try to build a container based out of the current directory that I was in following a Docker file. Really, it just needs a path to a Docker file and the tag that it would be given, or the name of that container's image. Now, if you wanted to explore more of how the Docker file is actually built, again, these are all the instructions and arguments that might be given. The structure is normally like a capital instruction, and then what you would supply following that. We tried to use run, and there are others that we might end up exploring. I used from to give it sort of a skeleton or a blueprint to start with, but we don't need to dive too deep into the weeds here. Really, it showcases if anyone has any interest and some exercise for the reader, you're welcome to explore that. But oh goodness, did I start to do some of the stuff already done here? Oh, they also have an example of a Docker file. Let's go explore that for a moment. Here it is. You can see there is a from line, volumes that it might be using, and then commands that are ran at build time when you build an image with that Docker build command. You expose a port, and then you specify a command to run. That's all the case may be. All right. With that said, we made a directory AOC for Advent of Cyber after we were exiting our container that we were currently in, right? And then we would use Docker save as a command to actually pull out all of the layers and maybe store them as a tar archive or that tape archive given a specific tag. And then we could actually verify, oh, do we have that file present in our working directory? And let me review that. Sorry, I know I'm bouncing around, but I'll go ahead and exit out of the shell that we're currently in. I'll ls, and all I have is this old Docker file that I used for the demonstration. We don't need that, but let's go ahead and use Docker save. And we'll need tac-o to specify the output file. They gave the example aoc.tar as where we want to save this to. I'll do the same, and then you could try and tab complete what specific image name you'd like. So I started to type the word public and then hit tab a few times for Docker to be able to expand that for us. Again, you don't exactly need the latest, but it's good to have that tag if you'd like to. And then once this command is ran, I'll hit enter. Takes a little bit because it's bundling it all up, wrapping the present. But if I hit ls, wow, we have a whopping 517 megabytes of that AOC tar file. Now, once we've saved that image, you can further expect it by trying to extract or unpack that compressed file. tar tac xf. I'll go ahead and do that. I'll use tar xvf with aoc.tar, so it's verbose, and I can see everything that's pulled out. And there's a lot of stuff here, right? I'll scroll out or zoom out and notice that there are a lot of seemingly hashes, identifiers, kind of as we saw. And again, Docker is just using a string of hexadecimal characters to denote each and every single layer, or every time the original author might have used that Docker build command, because it keeps stacking and putting new stuff inside of the container image. There is seemingly the last one, or a JSON configuration, manifest, and repositories that we could explore, but notice that the TryHackMe room explains this just as well for us. It says these files represent the various container image layers, with the exception of the manifest.json file. Manifest.json represents the manifest of a container image and the layers that compose the final container image we were just inside. Let's take a look at this image using a tool called JQ to pretty print the output for easier readability. Now, this has been installed already on the attack box if folks are experimenting and playing with that. Notice this is done because the manifest.json file just dumps this out all in one long line, which can be a little bit tough to read. So you could use something like JQ to run it on that specific file, but they use, I believe, a specific syntax or just pipe it from cat. You could print the contents of the manifest.json to the terminal using JQ to pretty print it and expand this so it's not all one long line that wraps around. Let's do that. Let's use cat manifest and pipe it to JQ. And now all of this is displayed in a much nicer way for us. You can see the config, current JSON, and then the other layers that might be built in layer.tar in each of these. Very cool. We could dive into those if we'd like. Note the first piece of information of the file is config, which represents the underlying configurations and commands used to build the container image. The big long hash f886f00 blah blah blah.json, that's a configuration file also located in the root of the unpacked container image directory, as we saw just below and actually inside of our own directory here. Very nice. We could explore that. We could expect that or inspect that in the same manner as the manifest.json. I'll go ahead and tab complete that. We know it is the F8 one, and I'll pipe that to JQ just here. Very nice. You could see the different IDs and the layers down at the very, very bottom. But if I scrolled up, and there's a lot to scroll up through, so forgive me. Here we go. We're back at the top. There's the architecture, maybe the user that's specified, the path environment variables, as well as the API key environment variable, and an image given a tag or a given identifier. Entry point for the command to run, simple sh to run a shell, container ID, host name, and this might be what you already saw in our host name as we were interacting with the image or the container. But if we were to scroll down, you might be able to see some other interesting things, like potentially adding files, or even specifying things that we want to run and do as we build the container, right? Inside what would have been the Docker file as the cookbook and the instructions for how to create this Docker container and that image here. Looks like we went ahead and upgraded some repositories and updated things as necessary. We installed curl, installed Python 3, pip, and git, and we even cloned some interesting projects, maybe env console or env console. We added the new user. We made sure that we were going to become that new user, change the working directory, set the API key, etc., etc. And that's all stuff that we would be able to explore and look through within this configuration file, especially with JQ, to make it easier for us to see. Now let's see what TryHackMe explains here. It says the first section of the manifest configuration file walks through the final image configuration as intended to be ran and run on a container host system, or your computer, or my computer, or the host spinning up this Docker instance with Docker run. However, the next section of particular interest to an attacker because it explains how the container image was built. You can see each section broken up by curly braces, and some of the section have an extra line indicating it's an empty layer, or empty layer is true, right? Nice. This is everything that we were just scrolling through moments ago. Each of these sections are describing a particular command run by the Docker daemon at the time the image was built, just as we explained. And if the empty layer is true configuration is not listed as part of the section definition, then the container layer is retained in the overall container image as one of the layers listed in that manifest.json file. Of particular interest, though, the one that we were kind of just wondering about, we notice the container contains a tool called env console that's pulled down from GitHub. Reviewing the GitHub repository for env console, the about description states that env console, or however you want to pronounce this, is a tool that allows users to launch a sub-process with environment variables using data from HashiCorp console and Vault. Noting that this source code was cloned into a root directory, perhaps there's something sensitive related to env console that a regular container user isn't intended to see at Grinch Enterprises. Now, before I keep cruising, let's actually go verify and look through this env console GitHub repository. This is the about description that we just saw. But scrolling down, maybe the README tells us a little bit more. Tool is inspired by envdir and envchain. Works on a majority operating systems. It also is available via Docker for scheduled environments. Very slick. But maybe that will allow us to do particular things that only those that have an API key or some special and sensitive environment variables would be able to do. So we're starting to pull on a thread here of an interesting story and use case. And let's really read through what TryHackMe is trying to bring us through. We'll hop back to that. Read the storyline here. It says, let's dig through the image layers and see if we can find out what is so sensitive about env or env console. We can more closely inspect the layers by switching to the subdirectories, each of those hashes you knew that had kind of a specific ID or a long string of hex, and unpacking each of these. As we switch between these layers, we notice that one layer has special, interesting attributes and properties. So let's go do this. Let me hit ls, and you can see that there were a couple of these potential subdirectories. I might do something odd, and that, sure, we could bop in kind of control in each of these, see if there's anything worthwhile or interesting. And do they actually extract each of these? Yes, they do. They try and use tar to extract each new layer.tar. So let's do exactly that. I'll again use tar xvf on that layer.tar. And ooh, actually right away, that's seemingly interesting. there was a root directory that had some files for that env console and a particular config file. So let's move into that directory. And here is this config file. Is this what we should be exploring? Ooh, yeah, they go ahead and cat this out. And they say, this denotes the start of the configuration section for console. All values contained in this section pertain to console. And I'm assuming console has some other utility that could be given by HashiCorp or HashiCorp as they explain this below. Actually clicking on that link to go view it. Yeah, console, service mesh for any runtime or cloud. So this has to be something, maybe how they're working with their own technology, their own stack over at Grinch Enterprises. So this could be interesting to dig into. Set up an address, how this is listening or looking on a bind address, how they want to run a service. It says this layer contains a config.hcl file. As we look in this file in the container image layer, it's clear that the sensitive configurations are maintained in that file. So let's use a command line tool called grep and see if we can return a secret or a token. Well, we could do this. We could actually go ahead and cat out our own file. And there is a lot of output here. Let's try and open this up in Sublime Text. And I'm going to go ahead and set the syntax here to bash, so this is a little bit easier to read. Even then, it's not all that much. Let's try and use something like Python so we can better see things that aren't comments. Scrolling down, a couple retry attempts, configurations, settings, and specified, server name. Oh, it looks like something is running an app as a command. Other information. But are there any potential secrets or anything really interesting? Ooh, keys that might be supplied or passed in somewhere. Ooh, secrets. These doesn't contain anything at the moment. Ooh, but vault is kind of interesting. No, this looks almost just like a regular real thing out in the real world. But token looks especially interesting. This must be the vault token for whatever's being set here. We also see a service being set up with keys, but okay, maybe this token is the only thing that could be valuable later on. Let's go continue reading. They had done this where they just catted the file and grepped for that token. They found a lot of potential options, but it also would have displayed a token being set to something. Ooh. And I believe this is the end of our exploration. Maybe we just found something sensitive that could be used to potentially take control of the vault or other special attributes or services used by Grinch Enterprises. Let's answer some of these questions here, and maybe that's all for us today to close up our TryHackMe Advent of Cyber 3 Day 18. But it says, what command will list container images stored in your local container registry? I believe that was Docker images, correct? Hit submit. Yes, that's the correct answer. What command will allow you to save a Docker image as a tar archive? We saw that was Docker save, correct? What is the name of the file, including file extension, for the configuration, repository tags, and layer hash values stored in a container image? That was that manifest.json. We were able to explore that with JQ. You can submit that. And what is the token value that you found for the bonus challenge? Well, going back inside of our terminal here, scrolling through this when we were looking in Sublime Text and through the command line, we had this value, which must be something super sensitive. Maybe allowing us greater access into something more. But that is all that's given for day 18 here. And I think that was kind of a neat, cool introduction to some things you might be able to do with Docker and really just being able to dig into how these containers are built and how they're saved, even if it's not specific to AWS. We were able to pull down this public repository hosted on AWS, but we could do the very same with any Docker repository. Things that you have locally, things that I have locally, as I could work through as an example on my own box, or maybe just Docker Hub, like the online public official Docker repository. So that's kind of neat. If folks aren't familiar with Docker, it is incredible to be able to spin up applications super quick, super easy, and do different things. But I would really recommend it if folks wanted to explore and play with it. Again, you just bundle up an application, whether it's tools that you use or vulnerable services, right, for capture the flag sake or trying to showcase maybe some cool proof of concept or exploit. If folks hadn't seen like the Log4j video I did, we spun up a Docker container because it had a vulnerable application inside that we could again test and explore. Or you might just be using it for infrastructure, building things, deploying things, and it's spun up with potential keys to do better unit tests or more information. There are so many different use cases, and when we get to play with containers just like this and even explore and dissect them and inspect how it's built, you get a lot of value out of it. And if you find someone else's container some way, somehow, you can inspect and save that to peel apart the layers and better understand it. So that's all. That's all we're going to be showcasing today. I hope it was fun. I hope you learned something new. And I hope if you haven't played with Docker before, you certainly will now. I really recommend go Google around, go take a look at their tutorial, their getting started steps, and you won't be disappointed. It will seriously add a whole new perspective to everything that you end up doing within security and with your computer here. All the fun stuff that we do. Thanks so much for watching, everybody. I hope you enjoyed this video. I'll see you in the next one. I love you. Take care.